Another factor that can have a significant impact on the usefulness of a CCTV image is the depth of field. This is the extent of the area in front of and behind the main object of interest that appears in focus. Generally, the greater the depth of field, the better the image is for CCTV observation, because this means that it's not just the required object of interest that's in focus, but other objects in the foreground and background will also be clearly visible. The main factor that influences the depth of field is the lens aperture, the size of the opening on the lens that allows light to pass through to the camera sensor. The aperture normally varies with lighting conditions, and there's a corresponding variation in the depth of field. In low light conditions, the depth of field is at a minimum. This is because the lens aperture is fully open, so as to allow as much light as possible through to the camera sensor. The best way to maintain a constant depth of field is to provide appropriate lighting for the scene. In daylight, the camera can use a small aperture. This gives the shot a good depth of field, so that the whole area is clearly visible. But in low light conditions, the lens aperture is much larger and the depth of field is greatly reduced. Only a certain portion of the area is now clearly visible. Outside this area, activity is out of focus and is highly likely to go undetected. Where possible, the best solution is to install sufficient lights. This means that the camera can use a small aperture and maintain a good depth of field. When defining the operational requirements for individual cameras, you must ensure that you have allowed for the worst case scenario where light levels are at a minimum. A common failure with many CCTV systems is that the depth of field is not checked in low light conditions. You can see that the depth of field's an important consideration and one that needs to be carefully specified in the operational requirement. Ask the questions: are we using the right combination of lighting, camera and lens? And can observers clearly see the objects or activity of interest in all types of conditions under which the camera will be expected to work?